Let us see about MOSFET drain transfer characteristics, current equation and pinch of voltage and significance, threshold voltage and the small signal characteristic. Symbol for MOSFET in the that is depletion mode, and this is the second one is for enhancement mode. The N channel MOSFET are simply called as NMOS, and this symbol is known as the symbol for N channel MOSFET. While we are going for the construction of N channel MOSFET, a lightly doped P-type substrate is taken into which two heavily doped N-type regions are diffused and which acts as the source and drain between these two N plus regions, and this occurs diffusion to form an N channel connecting drain and sources. A thin layer of silicon dioxide is grown over the entire surface and holes are made to draw the ohmic contacts for the drain and source terminals. A conducting layer of aluminum is laid over the entire channel upon this silicon layer from source to drain, which constitute the gate. The SiO2 substrate is connected to the common or ground terminal. Because of this construction, the MOSFET has a very less chip area than BJT, which is 5% of the common when compared to bipolar junction transistor. This device can be operated in modes, and they are depletion and enhancement modes. Here, this is the construction of N-channel MOSFET. While we are going for this N-channel MOSFET in the enhancement mode, the same MOSFET can be worked in enhancement mode if we can change the polarities of the voltages VE, so that they consider the MOSFET with gate source voltage VGG being positive. When no voltage is applied between the gate and the source, some current flows due to the voltage between the drain and source, and let some positive voltage is applied at VGG. Then the minority carriers, that is the holes get repelled, and the minority carriers, that is the electrons, get attracted towards the silicon layer with some amount of positive potential at VGG. At certain amount of drain current ID flows through the source to drain. When the positive potential is further increased, the current ID increases due to the flow of electrons from source, and they are and those are pushed due to the voltage applied at VGE. Hence, the more positive the applied VGE, the more the value of drain current ID will be, and also the current flows get enhanced due to the increase in electron holes better than its depletion layer. And this mode is termed as the enhancement mode MOSFET. And here this is the N channel enhancement mode. Here, while we are going for this, there is a NPN junction present between the gate and the channel, and this is called as the diffused channel N between the two N plus region and the insulating dielectric SiO2, and then the aluminum thin layer form the gate together form the parallel plate capacitor. If the NMOS has to be worked as in depletion mode, the gate terminal should be in the positive terminal, where the drain is in the positive potential as shown in the following figure. When no voltages is applied between the gate and the source, some current flows due to the voltage between the drain and the source, that some negative voltages is applied at VGG. Then the minority carrier, that is the holes, get attracted and settle near SiO2 layer, but the minority carriers, that is the electron, get repelled when some amount of negative potential at VGG at certain amount of drain current ID flows through the source to drain, and when the negative voltages is further increased, the electron get depleted and the current ID decreases. Hence, the more negative the applied VGG, the lesser the value of drain current ID, and will be the channel near to drain gets more depleted, and then the source like the GFET and the gate and the current force decreases due to this effect. And here, while we are going for this is the depletion mode of MOSFET, and here the drain characteristics of the MOSFET are drawn between the drain current and the drain source voltages VDS, and here this is the characteristics of this depletion mode and the enhancement mode. And while we are having the transfer characteristics, here it is defined the change in the value of VDS with the change in ID and VGS in both the depletion and enhancement mode, and this is the transfer characteristics of N channel depletion mode and enhancement mode. Thank you.